So in this problem, we are looking for the x-coordinate that is closest to the origin. So we're going to try to minimize our distance. And so here's the origin. The origin is at 0, 0. It looks like the point that we want is going to be pretty low on the graph, but I'll put it here just because it could be any distance. We know that's not the minimum distance. This has coordinates x comma y. But more specifically, the y-coordinate is 2x plus 3 because that's equal to y. And now we know our distance formula, I'll call it d, is equal to the square root of x minus x1 squared plus y minus y1 squared. This is really just our Pythagorean theorem. It comes from c squared equals a squared plus b squared. Solving everything gives us this distance formula. Well, we know that our x1 and y1 are 0, 0 because that's the origin. Well, our x is just x, and our y is that 2x plus 3. So now we're looking at the distance equals the square root of x squared plus 2x plus 3 squared. Just so that you didn't have to wait for me to do like algebra 2 stuff, we did our box method here. I expanded this 2x plus 3 squared out. Our distance is equal to the square root of 5x squared plus 12x plus 9. And that's what we want to minimize. So if we're going to minimize our distance, I need to take its derivative and set it equal to 0. I'm going to rewrite this derivative to the 1/2 power so that it's easier to take the derivative. D prime will be 1/2 the 5x squared plus 12x plus 9 to the negative 1/2 times the derivative of the inner, 10x plus 12. Or written another way, we're really saying d prime is 10x plus 12 over the square root of 5x squared plus 12x plus 9, and there's a 2 down here. And we want this to be equal to 0 or potentially undefined. We could have a cuspy max or min. Well, if we want it to be equal to 0, it's just when the numerator will equal to 0. If we want it to be undefined, it's when the denominator will equal to 0. Well, this is probably never going to equal 0 because all these are plus, and we can't have a negative x. Well, I guess we could have a negative x. But we're going to solve this numerator equal to 0. 10x equals negative 12. X equals negative 12 over 10, or negative 6 over 5. What is the x-coordinate of the point, the graph closest to the origin? We've found it. Our last thing would be just to make sure, like, hey, is this a max? Let's just double check. If we were to graph 10x plus 12, this graph would have a intercept up here at 12 and have positive slope. So this right here, the derivative, d prime, is going from negative to positive, making this a min. And that's what we wanted. We wanted the closest or the minimum distance. So we found our answer.